Question 10. Use idea about particles to explain how a gas causes a pressure on the inside of a container. It's 3 marks, so they're looking for 3 bullet points. First bullet point is that the particles are constantly moving and that their motion is random. Second bullet point is that when these gas particles collide with the walls, then they will exert a force on the walls. There we go. And finally, because pressure equals force divided by area, this force of the colliding gas particles with the walls of the container, as these collide with the internal surface area of the walls, that's going to result in a pressure on the walls. So how would increasing the temperature of the compressed gas affect the pressure of the can? It's going to increase, try again, it's going to increase the pressure in the can, and now we've got to explain our answer. So when we increase the temperature, then we're increasing the speed, or the average kinetic energy of the gas particles. To get the second marking point, we can either say that because they're moving faster, they will either collide with the walls of the container more frequently, or also because they're moving faster, each collision is going to have more force. So either of those explanations are okay for the second marking point. For part C, it's asking us about the volume and the pressure, and it's asking us to calculate the new volume. So we need a formula that links pressure and volume together. Hopefully you can remember what it is, but if you can't, this is actually one of the ones that's given at the front of the exam paper. So you turn to the front of the exam paper. There we go, that's the equation that we're after. So you don't get any marks for writing the formula, unfortunately, because they've already given it to you in the question paper. Okay, so now we've got to think, how do we use it? Well, situation 1 is here, okay, and you can see that to start off with, it's got a volume of 400 centimeters cubed, and it's got a pressure of 5 atmospheres, so we'll put that in there. So it's 5 atmospheres times by 400 centimeters cubed, and then it's asking us here, this is situation 2, okay, so it's asking us for the volume, so that's the bit that we don't know, so we'll leave that as a letter, that the air would occupy if it was all released to atmospheric pressure. So the pressure at atmospheric pressure is 1 atmosphere. Now, because of the nature of this equation, it doesn't matter what units you use for pressure, because they just cancel out, so you can use it with atmospheres or bars or pascals, and then the units for volume are the same. As long as they're the same on each side of the equation, then that's absolutely fine. So the volume is 2000 centimeters cubed.